Good morning. We've got a different project on the go today here. We're looking at distilling and processing our own drinking water. We live off the main water grid, so we do not have treated water at our disposal. And generally speaking, we go into town and just fill water jugs. However, we thought we do have good water out here, it's just not treated. So we thought we'd look into some different techniques of making our own water. My first pick being the solar distiller. However, we are out in minus 20, minus 30 right now in our lovely Canadian winter. So a solar one is not a very valid option here. So you'll see I have rigged up an old electric frying pan. I've reversed the lid, put the handle on the top so the dome goes down, and you'll see the beads of water that evaporate. Follow that down and they're actually landing on a collector down there, which actually comes through the frying pan and just down a little stretch of hose here. And I'm just trying to monitor here how cost effective this would be to attempt an electric distiller. Keeping in mind we're not just going to distill. Before the distiller would be 3 carbon filters, and after the distiller would be a chlorination. It would get chlorinated. But I just happened to throw up this makeshift fan that I have built for my greenhouse to see how the cooling increases the productivity of it, and quite a bit more production out of it by cooling. This isn't the original design I had. I just decided an electric fry pan was the way to go, an old one, and once the Teflon comes off them, they have to be good for something. Now running an electric fry pan all day, let alone a blower, is not exactly what I had in mind. For the winter, the electric fry pan would be fine because it is thermostatically controlled and it kind of cuts in and out as needed. But blowing cool air on it isn't really what I had in mind. I just thought I'd see what kind of results I'd get. I think the reason being this lid is running hot and the water isn't condensing as quickly as it could. It's still steaming, and you'll see I have some steam escaping here around this this lid, which once I get this performing the way I want, I'll actually use some foil tape, some aluminum foil tape, and seal that lid up. And we're going to put some charcoal actually in with the the water being treated. It's supposed to enhance the flavor. It takes away that kind of that dry, pasty taste, or I'm hoping it does anyway, because that's kind of what we're getting here. And then we just have to open that up every once in a while to service up, to clean up the residue inside the distiller there. So that's kind of where we're at here. I'm getting, you might say, a steady drip here, but we only consume probably 1 gallon to 2 gallons tops per day. That's probably a high estimate. I think a 5-gallon jug will generally do us a week. We use it mainly for cooking and coffee, so you can see with any luck we wouldn't have to run this thing day and night. We just keep ourselves, do a few jugs and then shut her down. And we do have what we call work water. It's untreated. We just use that for bathing and for dishwashing and household chores and whatnot. So I just wanted to get this here down. I'll go into a little bit more detail on the frying pan here, but I think my original plan was this glass, not even being domed, would be up quite a ways and sloped, giving it a chance to cool. This lid idea, that was just kind of a makeshift thing at the time. So that's what we're up to here today. We're still got our barrel heater in the works. It's still kind of been, we kind of had a cold snap here, so I'm not real anxious to go running outside. So I'm gonna have some more updates on that as well, and I'll maybe see if this distiller is even gonna be a go. I just thought I'd throw this up there on maybe some different ideas, and anyone else looking at the same ideas. That fan has definitely increased production here, because before it would just come out, it would build, and then it'd come out as a blurp. But it's virtually a steady drip now, and that if a guy can keep it steady like that, he could easily calculate what he needs to operate it. Like I say, I don't want to be running the power bill way up, because we don't pay for water. We just kind of go into town and borrow it, if you will. So I'll keep posted on this here, on this idea, and I'll maybe, if it does turn out, I'll shoot some more clarity on how I drilled the hole through the pan and got it watertight and heat proof, that sort of thing. Keeping in mind we're dealing with drinking water, so you have to kind of keep things, you don't want to make your family sick with the drinking water, so you want to keep the parts you use something that's approved by a food agency or something. You know, that's why I used, I don't know if you could see in there, that's actually a lid off a pickle jar, things like that. There's some stainless steel, there's some brass, some galvanized, and that's a new piece of vinyl tubing there. So frying pan, that's obviously CSA approved, things like that. We don't want to be welding and slapping crap together here that's going to make us sick. So just thought I'd mention that. Out for now. Alright, here we are again. Wile E. Coyote Super Genius here. Went into the house and stole a boot rack, so thankfully the missus is in town. So, gotta get this thing working before she gets back. So I've got the water supply modestly dripping relative to what I thought the distiller was putting out. It's dripping into a carbon filter. It's in a bag there. I've just got a little hole drilled in the top there. It's kind of a funnel shape on the bottom of the jar. Coming out of that into a potable water stainless steel coated line, typically found on faucets and stuff in the house. Just did a makeshift job on the tie-in there. That's going to drip down onto the lid. And the reason I'm doing that is the cool water will help condense the water underneath the lid even quicker, rather than blowing a fan on it. There is a little hole there, you'll see. It's a steam hole. It's original to the frying pan, and you wouldn't believe how nicely it just trickles into there. So right now we're basically waiting for this filter to saturate, fill, and I just seen a water drip somewhere, almost like I'm leaking. Yeah, I am leaking a little bit there. And anyway, I'll get my leak fixed there, and I'll see what we can do here. Alright, here we are again. Got all the little things fixed up on her. Got my water jug dripping into my carbon filter. Carbon filter runs through onto the lid. Lid helps, or the water on the lid cools the steam underneath. It drips through that little tiny hole there. I had to put a little piece of aluminum tape there to get it to drip, so it didn't run down into the center. Frying pan heats, it goes through that, drops onto that lid there, through the bottom of the pan, out this hose, and down into my cup. Right now I'm doing a timer here to see how long it takes me to make 1 cup. And you see we're at 3/4 of a cup already, and let's see what my timer's at. 4, almost 5 minutes here. So it's looking like we're going to be able to do a cup, you know, in about the 6 minutes. So after this, we go carbon, distillation, and then we're going to go chlorination. I don't have the chlorine here yet, but I am figuring all the bugs on this end of things first. And this will be a system we're going to set up in our basement, and we can just distill water as needed. So we're about 3¼ cups. So looking at my clock here, 5 minutes and 30 seconds. So I'd say about a 7-minute cup. It's running a little bit quicker than I expected, to be honest, but that water on the top of that lid really seems to help. Not only that, it preheats the water so that you're actually, it's a little bit more efficient because you're not wasting as much heat. I'm going to take some aluminum tape and tape off the edges here, but I don't want to do that yet because they claim if you put carbon in the distillation process, makes the water taste better. So I want to get 2 cups as samples, one with, one without, see which one we like better. So I'm down there at a cup here already. So you can see we're just approaching the cup there, so you kind of get a sense of how quickly that's actually filling. And you'll see there's lots of steam escaping, so it may even be quicker with that tape on there. So anyway, that's kind of where we're at here. Just thought I'd give you an update on how things are going. So that's where the water exits the lid top and drops through into the burner there. And then from the burner, it evaporates back up to the lid, rolls down the curve of the lid and drops into that pickle jar lid, which has a hole through the center, which actually goes right through the frying pan. And then it comes out this hose here. And right now I'm just draining it into a measuring cup to see what kind of performance we're getting. And we were actually sitting on the 7-minute cup is the last measurement here. Just thought I'd show you some close-ups of what's actually happening there. Okay, here we are again. The best part about building your own crap is the failure, because it just means you have to work a little harder at it. So here's, while I have this apart, I just have a hole going through. I just made up my own little adapter to get through the bottom of the pan. And then there's just this pickle lid jar here, which basically funnels everything down into that center spot there off of my lid, which I've reversed the handle on, as you can see. So we've got this dish here. So what I've done, or the principle I'm working on here, is I trickle my carbon filtered water onto this lid. It cools this lid as it drops through this hole, and it's just a drip. You can only drip it in as quickly as you can evaporate it. I've put this little piece of aluminum foil tape so that when the water drips through that hole, it doesn't chase down and get picked up by the Bix pickle lid. So that part of it's working fine, but what I'm finding happens is when you run it prolonged, the water on here is only a drip, and it's getting this water too hot, and therefore it's not condensing the steam on the underside of the lid. So it kind of gets into almost a remission, if you will, where it doesn't really accomplish anything once this water gets all smoking hot here. So obviously I need this cooler to get what would you call it, an efficient reaction here. And this is, like I say, if this is going to cost me $15 to make a jug of water, well, I'm much better off to just keep hauling it by the jug. So I'm just going to experiment here. What I originally had planned on doing is building a big box which accommodates solar power. However, like I was saying, solar power in the wintertime is great, except that my water is going to freeze. Excuse me. So what I'm going to do here is I'm just going to try a bit of an experiment. And I'm going to hold a piece of glass up above the steam and see how far away I have to be to get a good reaction with just the atmosphere cooling the glass. I don't really want to run a fan, or I've seen people use ice and stuff. Well, that just doesn't pay. That makes it work. That's good for a science experiment. But so I have a sheet of glass down here. I'm going to dig out. I actually have some Lexan back there too. And I'm just going to try this here, and we'll see if we can get some sort of an idea going here about putting a box around the whole frying pan. And we'll build a box completely around the frying pan so that all the steam from the frying pan comes up onto a sloped sheet of glass. And that glass would have a collector at the end of it, which would then drip it off into our good water supply. So hang with me here and I'll see what I can get worked up.